In this video, you are going to learn about hierarchical linear regression. Remember that in order to make this video, we use resources from the internet and from other individuals who have tried to do similar work. So please visit these links, and we'd like to give credit, and this is our citation list. Hierarchical multiple regression, like standard multiple regression, HMR, or hierarchical multiple regression, also known as sequential multiple regression, allows you to predict a dependent variable based on multiple independent variables. However, the procedure is different from standard multiple regression. In standard multiple regression, all the independent variables are entered into the regression equation at the same time. By contrast, HMR enables you to enter the independent variables into the regression equation in the order of your choosing. HMR can tell you how much extra variation in the dependent variable can be explained by the addition of one or more independent variables. HMR allows you to control for the effects of covariates on your results and take into account the possible causal effects of independent variables when predicting a dependent variable. Today, remember that our data are for educational purposes only and shouldn't inform your opinion about the subject matter. Our research question today is the same that we had for multiple linear regression. Can we predict a speaking score in learners of English? And imagine that we recruited 100 participants to perform a speaking test. We recorded their age, anxiety levels prior to taking the test, average study time, and whether or not they lived in an English-speaking country for any amount of time before taking the test. We are interested in whether the addition of anxiety level before the test and then study time obtained improved the prediction of speaking scores over and above age and whether or not participants had lived in an English-speaking country. So these two are our covariates, age and whether or not they lived in an English-speaking country. Remember that this scenario and these data are not real, and they're only for educational purposes. First, we'll load some packages that we'll use today. And then we'll load our data. And we'll take a look at our data. As you can see, here are our variables. We have age, anxiety level before the test, study time in minutes. Lived in an English-speaking country is coded as 1 and 0. So 1 means yes, the person has lived in an English-speaking country, and 0 means no, that they have not prior to taking the test. And here's our speaking score. Here we have our assumptions that we're going to need to meet in order to make our model fit. And we're going to get right into the regression. Here, we need to make multiple models in order to enter our variables into the hierarchical multiple regression in order. So first, we have our covariates in the first model, and then we add anxiety level, and then we add study time. So we run this code, get our 3 models, and when we take a look at our 3 models, we can see the change in between each model. Unlike, for example, SPSS, if you were to run a hierarchical multiple regression in SPSS, you would automatically get an output of, for example, the change in your R² between each model. Because we're working with R, you would have to do this calculation manually, but you have the information here. So for example, in the third model, you can see what your R² is, and then you can take a look at your second model, and you can do the same thing for your first model, along with your other coefficients and any other information that you want to include in your write-up afterward. Here is the ANOVA that we would run on all three models. And our outlier test. We see that we have an outlier, but it's not significant, so we're going to leave it in the data for now. To get standardized regression coefficients, we run this code, and you can include these standardized regression coefficients in your write-up. We get some more information from the influence function, and you can take a look through that. Get the Durbin-Watson statistic, which comes out to approximately 2, which is what we're looking for. We can plot a histogram of our standardized residuals for specifically model 3. And we can see that they're approximately normal. And we can look at a normality plot as well. Here, linearity of the studentized residuals versus predicted values is important. And the independent variables collectively should be linear related to the dependent variable. And we see that they indeed are. We have a linear relationship. And again, for linearity, each independent variable should be linearly related to the dependent variable. And we look at the partial regression plots for that. We can see that in each case, we do have a linear relationship. We check multicollinearity. And finally, homoscedasticity. And we can see here that we do indeed have a linear relationship.